Good morning. So, in this session, we are going to talk about cleaning and sanitation. Food processing involves, preserving, take the raw material, convert it into edible food through pasteurization, sterilization, and many other operations. But one of the important step is the cleaning and sanitation, because you want to make sure that the environment, the plant where you are processing food is free from pathogens and spoilage organisms, other chemical hazards and things of that nature. So, when you are looking at the food processing plant, there may be a variety of things you may find. Let's suppose you are processing some flour, you may kind of have a flour spread on the floor. You may have water, because food processing, we use a lot of water for cleaning, various aspects. You may have allergens, and again, like some other things maybe doesn't bother some people, but if you are allergic to some of those things, like now, for example, nuts and things like that, then it's a concern. The employees come from home, so they may brought some contaminants, and usually when you sanitize, you use chemicals, and if you don't properly sanitize, you may have some chemical residues. Of course, the microorganisms are there, and you probably have birds and other animals in the neighborhood, so they may try to drop things and so on and so forth, and that can be a problem. So, you have to make sure when you do the cleaning and sanitation, all these things kind of taken care of. When you do the cleaning and sanitation, you want to remove the microbiological load, allergens, and then you want to make sure it's visually and functionally clean, and there are certain similar requirement for organic labeling, kosher, halal requirement. So, you have to kind of take care of all those things. Oftentimes, when you look at the regulations, they are often talk about what they call food contact surface. So, food contact surface is where the food product is kind of directly come in contact with the equipment surfaces. So, for example, if you think about heat exchangers, the interior of the heat exchanger where the food is flowing through is an example for food contact surface. Or you are cutting some fruits and vegetables on a table, that may be another example for food contact surface. So, those food contact surfaces should free from all these residues we talked earlier. So, we have to remove them, so that we have a reduce and minimize the opportunity for cross contamination, and then they also want to avoid any potential microbiological growth. So, a lot of times, for example, you think about a table or a small equipment surface, there may be small holes in there, and you may have some food residue go and deposit there along with water. That means it's a good source for microorganisms, and if you don't check this properly, they start kind of growing there, and then that's a source of contamination. So, that's something we need to worry about. And typically, when you do the cleaning and sanitation, you have to look at this in a different zone level. The zone 1 is where the actual processing takes place. So, probably this is where your pasteurization equipment may be there, or your cutting board, or your heat exchangers, all the food processing is happening here. Then zone 2 is non-food contact surface, but it's close to that, because since it's very close, it's easy for the microorganisms to get in from the zone 2 to zone 1 quite easily. So, you have to think about that. And then zone 3 is a little bit remote from process area, but potentially you can able to have this. So, for example, you can think about processing in a room, then you probably have adjacent storage rooms where you may be keeping a lot of raw materials, and then you may have warehouse, and then you have parking lot in the building. So, it's kind of go away from the processing zone. So, each one you have to do it, but the key thing is to make sure that the food contact surface, this zone, is properly sanitized. When I say cleaning, it's probably maybe simple. It's an action of making something clean. But how clean is clean? So, if I have a surface, I have some dust on the table, I can just remove the dust. Visually I look at it, it may look clean. But if I look at using a microscope or some other means, there may be still microorganisms attached to it, or maybe the other chemicals may be microscopically attached to the table. So, cleaning means you have to have certain criteria for cleaning, so that it is not like, okay, for me it looks okay clean, so I am going to done with that, whereas somebody else say, okay, this is not clean enough for me. So, there should be a consistent definition, so everyone agree upon. So, that is something needs to be discussed. The other thing, when you do with the process equipment, we talked about this foulant. So, for example, when you are pasteurizing milk, you probably have some protein films can be deposited. So, this is a residue collecting on the surface as a result of contact between the surface and the product. So, that means maybe if you are processing some flour, there may be a deposit of flour may be there, and it's kind of a very thin layer, not necessarily very thick one. And then you may have protein deposits, other like starch deposits, other things may be there. And so, these are the things you have to also take care of in addition to your other residues. So, this is just to give you an example, a pipeline where you may be pasteurizing milk or you are processing juice, and if you look at it, it looks visually clean outside, but the fouling probably take place inside where the product is flowing through. So, that is where you have to take care of it. Or even when you have a juice flowing through, there may be some organic matter deposit there, and then that is something needs to do it. The same way, when you have a big tank like this, how are you going to clean, what needs to be done. So, this graph just to show how the fouling can progresses and influenced by two things. One, how much time you are processing your samples. The second, at what temperature you are processing. As you can probably see here, if you are processing at 138 Celsius, this is the one, you can see that the protein deposits aggregates much more and then deposit as a thin layer much quickly in even 20 minutes. Whereas, if you are processing at 127 Celsius, you can see here it takes almost like 60 minutes to reach a similar level. So, the temperature at which you are processing and what type of proteins you have or what type of things you have kind of determine how much fouling you may have during processings. Yesterday, we talked about biofilms. Biofilms can be formed on the surface. Basically, it's like a small thin layer of microorganisms, and they are much more difficult to remove compared to say even some of the foulant type thing, because microorganisms going to deposits in multiple layers, and then they kind of form a colony, and then they are much more active, and it requires much more greater effort. So, you need to have a specialized cleaning and sanitation technique needs to be there. Each product, meat, dairy, vegetables, they probably going to have different sanitizing and cleaning needs, because remember each one have different type of material. So, some of them may have more lipids in them, some of them have more proteins, some of them are carbohydrates. So, you have to kind of consider some of those things. Other thing you need to consider is cleaning and sanitation. It's the best interest of the company to do it, but it's also largely dictated by the regulations. So, for example, if you are processing products for Food and Drug Administration, government products like FDA has certain jurisdiction, which we'll talk later in the next presentation. They probably have certain recommendation how you do the cleaning sanitation. USDA, they may have meat products, they maybe have a different recommendations. Your local authorities may have a different recommendation. So you have to kind of think about all those things and make sure you satisfy those things. So what do you do for cleaning? Basically, you kind of use a cleaning agent like oftentimes a detergent with say water so that you can able to clean the surface. Second thing is you probably oftentimes you can probably clean this by pumping water at room temperature, but things will be much more effective if you do this at a relatively warmer temperature, say 60 or 70 Celsius, or depending on the operation. And then again, when you are cleaning, things may be attached to the surface. So, just rinsing water through that may not remove everything. So, some type of mechanical action. So, using a brush or other means, so that you can able to remove that better. And you also need to do this for sufficient time. Like in other words, like if you probably need make sure all the foulant and microorganisms, some other things, all are removed to the extent possible, part of the cleaning process. Now, is the cleaning the same as sanitation? Sanitation refers basically getting rid of the microorganisms to certain target level, whereas cleaning primarily refers to removal of the residues, your protein films, things of that nature during the process. So, the soil is clean, visible, and then you kind of clean it. On the other hand, once you clean it to the extent possible, still there is a possibility of microorganism attached to the surface, even though surface look visibly clean. So, you have to sanitize. So, for that you have to kill the microorganism or inactivate the microorganisms, and so that you can kind of do that. You have to do it for certain level. So, for example, maybe you need about 3 log reduction, or you need about 4 log reduction, depending on the type of agencies you are working with. So, you have to kind of target your sanitation treatment based on those recommendations. So, now we are talking here something called CIP. What is CIP? CIP calls for clean in place. So, what is clean in place? And what is also, there is something called COP, this is clean out of place. So, let us think about a simple jacketed vessel. It had some impeller to mix products in there. So, after use you have to clean. So, there are two ways you can do. One, you can just remove this impeller, go to a sink, and you can kind of wash it, you can kind of remove it, all the things. You wash this container, and then you can put them back, assemble them, and then you kind of have it ready. So, that is the example for clean up out place. So, you have to dismantle a lot of these small parts of the equipment, and then you kind of clean outside and then assemble them, put them back. But if you ever go to a food processing plant with so many equipment components like pasteurization or sterilization and so on, taking equipment parts, disassemble, put them back, clean, all those things takes a lot of time. So, most of the food process operation is done what they call clean in place. So, what clean in place means that, so imagine you have a pasteurization equipment, or as an example in the class we used, you have an aseptic processing line. So, the aseptic processing line had a raw material tank, it had a pump, it had heat exchangers, it had holding tube, it has cooling heat exchanger, and then it had what I call aseptic filling, all those things. So, so it has a multi components. So, how do you disassembling all those things, put them back, probably going to take a day or two. That means your production is going to get affected. So, that means it is not going to be a very effective process. So, the idea here is you do it without disassembling by maybe passing a pre-rinse step. So, there is a sequence of steps. First, you take that pasteurization or aseptic processing equipment, then you just rinse with water. So, that any deposits of, if you are processing some soup, you may have residue soup left inside the equipment surfaces and so on. So, you kind of clean them by rinsing with water. So, it is called pre-rinse. So, this will do two things. One, if it is anything readily dissolvable, it is kind of remove them. The second thing is, in case you kind of took some time off between processing your equipment and then you start your cleaning cycle, anything dried out, it will hydrate them, so that it may kind of easy to remove in the subsequent step. The second step is your cleaning agent. You may be removing the foulant, probably adding some type of cleaning agent like detergent or something like that. So, you add some detergent to your water, and then you pass through this whole entire area again, and then you do this at a certain concentration of your detergent at certain temperature, and then you do it for certain time. So, that you kind of want to make sure it's remove everything you can. The next step is, since you are passing through this detergent, there is going to be some detergent residue left within the equipment, and when you are going to process next time your soup again, that become a contaminant. So, you have to do is maybe do another rinse, so that you can remove your cleaning agent. Then you kind of have, maybe if you have inorganic residues, you probably do some acid cleaning. We will talk about some of the chemicals used for that later, and then you remove that acid by rinsing one more time. So, it is kind of if you look at here, food processing uses water quite a bit, because every step you start with water, and then you add some detergent, you rinse it, then you rinse it again, then you add acid, and then you rinse it again. So, this is going to be a lot of water is used. So, that is something probably later on we will talk. The technologies now being looked at is, can we do, how do I minimize the water use for the cleaning and sanitation. So, there are some efforts coming right now, but we will talk in the later slides. So, there are 4 factors affect the cleaning performance and efficiency. So, we said mechanical force. So, we talked about if you are using brushes, mechanically scrape them. So, what type of mechanical force you use, at what temperature you are sending your liquid cleaning solutions, and what is the cleaning concentration of the compounds. Are you using very dilute, or are you going to have very concentrated? So, what the appropriate concentration, and then how much contact time I have, and so on. We talked about clean out of place, and then we talked about clean in place. So, this should be CIP. So, CIP is probably what practiced in the more industrial environment. COP may be done maybe in a smaller place, where it may be much easier to manage such systems. Manual cleaning, obviously you kind of scrub and remove the heavy soil. The second is COP, you transport the parts to operation area to a cleaning and then do this. CIP is basically you do it in the same location. So, that is kind of the 3 different places. So, again when we talk about some of the brushes, these are not very sophisticated, these are simple, but very effective in terms of doing your cleaning. So, you can kind of see ranges of brushes and other things that's commonly used. Again, you can probably see here different scrapers, and you also have a rain sanitation tool, and then you can also use when you are doing cleaning, sometime what they can also do is they can apply vacuum simultaneously, so it kind of pick up the residue much more effectively, because otherwise the material may be still remain there. So, when you select a chemical for your cleaning purpose or detergent for cleaning purpose, how do you going to select? What type of criteria do you use? I think one of the first thing you need to use is this cleaning detergent should be effective against a wide range of soil. When I say soil, these are the what I call the dirt, the foulant, the things you want to get rid of, so that you may make the surface clean. This soil doesn't mean that the soil you find on the earth. So, it is more a dirty kind of thing, and it should have excellent wetting and fat emulsification and sequestration properties. Remember, most of the food contain lipids, they may have carbohydrates, proteins and so on. So, that means your detergent should be able to, depending on the which detergent you use, able to take care of all those things. And you want to have this done at a low concentration. Again, especially in the current environment, the food industry is kind of trying to reduce how much chemicals you use for cleaning and sanitation. So, you do not want to use very high concentration, but you kind of try to use reasonably low concentration, so that it is still effective in cleaning, but at the same time you are not polluting the environment with lot of detergents. And water is typically used as a cleaning agent. So, the detergent should be soluble and compatible with that. And lot of the times in the plant environment, you may have hard water. So, the hard water means like how much minerals and other things you may have in your water, and is this sometime you have a luxury of getting very pure water, but in a cleaning plant environment you may not have that luxury. So, you need to be able to see whether you can able to work with wide range of water, and you should have a low foaming capacity, so that you can able to rinse without any detergent residue. So, when you have foams, the foam settle down, it may have some detergent residues. So, you want to get rid of them. Now, at the end of the day, your detergent is used in a food grade environment. So, to the extent possible, you want to have that as a food grade, so that somebody even make a mistake, at least it is reasonably forgiving than if it become a toxic or any other dyes and other things, perfumes and things of that nature. And foremost, the regulations oftentimes dictate what type of detergents you use and so on. So, here we have different type of contaminants are here, like for example, sugar, starch, protein, fat, salt and so on. And then you can probably see here how which is kind of make them solubilize. So, if you can see here, water can solubilize like sugar and salt, whereas if you look at fat, protein and starch, they are better solubilized with the alkali type of solutions. And then when you are heating these type of contaminants, what type of effect it may have, because that makes them stick together surface much more there. And then when it does, is it easy to remove or difficult to remove? So, for example, when you have protein deposits, when you heat it, they are going to denature and adhere to the surface, and it may be very difficult to remove. So, you have to use some type of alkali and hypochlorite solution, so that you can able to remove some of these contaminants. Water is kind of used very commonly as we said earlier, so that it is used as a pre-rinsing step, and it also transport the cleaning compound to the area to be cleaned, and then transport the suspended soil from the surface to clean. So, water kind of function two things, right. One, you have the cleaning agent where you take that water and then transport to your CIP equipment. So, that is one. The second thing is, as the water is kind of water and detergent kind of wash away all the contaminants, that contaminants also going with the residue water. And you also need to rinse the cleaning compound. Finally, when you do the post rinse after your cleaning, you have to remove any residual solutions. What type of alkaline detergents are used? Typically, alkaline detergents are used to take care of organic residues, fats, oil, greases and protein. Sodium hydroxide and KOH are some of the common agents, and then hypochlorites and hydrogen peroxides, they are kind of help to remove some of the insoluble soil. Here you kind of try to highlight how appropriate levels of these detergents is needed. So, when you have detergent concentration, you can see that the axis here, time to clean, and you can see there is going to be particular concentration is going to keep the time to clean minimum. Then if you are going to increase the concentration, it probably make it more less effective. So, you have to look at what is that optimum concentration for a particular detergent. Same way, when you look at the temperature of the cleaning solution, you can probably how much time to clean. Generally, the time decreases with increase in temperature. And of course, you have to make sure that the equipment, the components of the equipment, they can tolerate the temperature, all those things. So, you have to keep that in mind. The next one is, let us say you are pumping your cleaning solution through a pipe. At what velocity you have to pump through the system. So, you can see here it is much more effective up to certain velocity, then further increase in velocity does not have much help. So, it is kind of remains about the same. So, initially when you flow through the pipe very slow, the cleaning may not take place effectively. If you increase the speed above certain speed, then it is going to become much more effective, then suddenly it becomes less effective again. So, in other words, if you are trying to clean in this region is as good as doing here, but you may be spending less energy in pumping the liquid. Whereas here you are doing it at a high temperature, you are going to have much more effective cleaning. So, you rather do it here, whereas in this case somewhere in this region you may want to do it rather than not having too little concentration or not too high concentration of the liquid. And oftentimes there are specialized devices like these type of sprinkler type mechanisms are used for cleaning difficult to clean areas. So, for example, when you have a tank, you may have just rinse the water by passing through this type of ball valve, so that it is much easier to remove. So, you have CIP solution in and CIP solution out, and you may have something like here, you can see that there is a swelling going on. So, you can able to get this done and delivered to the surface much more forcefully. So, that there is a mechanical action for cleaning. And when you do the cleaning thing, you do not want to make certain mistakes. So, for example, you may have two tanks. So, in this case you are pumping in the inlet CIP solution here and then get the output here, and then use the same output for cleaning the second one. So, that means the second one going to have inertia to the your detergent, it also carry a lot of the soil from the first one. So, that means this may not be effective. Whereas, in this case you are going to have two separate lines. So, that each one going to receive its own set of detergents and it is going to be much more effective. So, how clean is clean? So, the cleaning basically you have to look at the molecular level residue occur in a certain factor. So, for example, there are some specialized things you can probably do some swab test on the surface which is being cleaned and then analyze this with certain quick methods to see how much residue may be there in ppm level or even lower. So, you can able to say okay, this is kind of acceptable level and so on. Now, when you look at sanitation, remember sanitation is a method where you typically do after you are done with the cleaning. So, you kind of first start with cleaning and after you are done with the cleaning, then you do the sanitation. And sanitation typically involve potentially inactivating any microorganisms that may be present in the surface that is being cleaned. And in the sanitation, there are two broad classification. One is called wet sanitation, another is we will talk later what is called dry sanitation. What is wet sanitation? As the name implies, you are using water and certain antimicrobial agents to sanitize that surface. What is dry sanitation? So, there are instances where in a food processing plant you may be processing number of dry ingredients like maybe flour, milk powder, things like that, where you do not want to use water, because in those dry processing environment if you use water can hide in the small niches and crevices, and if there is a lot of powder go and deposit there, then they serve as a source for microorganisms to grow and cause a problem. So, in those dry processing environment, they do not allow water as a processing aid or cleaning aid. So, that means you have to use a different method for sanitize them, which we will talk about that later. So, like usually the sanitizing agent, which is basically the which you use for inactivating microorganisms, they are typically chlorine based solutions, hydrogen peroxide, quaternary ammonium compounds. So, they can able to help to inactivate some of the harmful microorganisms. Now, I think from a consumer perspective, these are all considered as chemicals. So, they do have a meaningful purpose in protecting the food safety of the processing plant, but consumer may think, oh, you are using chlorine or you are using some of the ammonium compounds and so on. I do not want any chemicals in my processed food, or they may worry that the residue can get into the food. So, again that is where you have to use the appropriate concentration. So, you have to also use proper sanitation time, so that they can able to remove effectively, and then after this you have to rinse with the potable water, so that you can remove any excess chemicals. So, this is always the rinsing after your chemical use, either before, after cleaning or after sanitation is important. Then you also do some type of swab test, so that, or you can use some type of ATP test. So, there may be microorganisms still there. So, ATP test basically going to be able to say are there any detectable microorganisms in the surface after it is being sanitized. So, what are the examples of chemical sanitizers like chlorine, iodine, and I think each has certain benefits, but at the same time certain risk. So, for example, while chlorine compounds, they are very good germicides, they can able to quite effectively inactivate microorganisms. They are very corrosive to metals, because you are trying to clean your food processing plant surfaces, and if chlorine going to pit or corrode your surface, your equipment life going to decrease, and your equipment is very expensive. So, that means you have to replace. So, it becomes a concern. Other concern is there is a potential health and safety concerns, because if some of the chlorine residue get into the food, that can be a concern too. Now, iodine probably has different forms, like for example, it can effective against bacteria, viruses and number of other organisms, but it can be a toxic in terms of when it is exposed. When you have iodine exposure, it may have some type of plastics, it can kind of provide some type of staining, and there are times it can cause irritation and so on and so forth as well. Quaternary ammonium compounds. So, these are all cationic surfactant, they can combine bactericidal and virucidal activity. They can deeply penetrate into the surface and good wearing agent, and they are typically used in floors and wall surfaces. So, hydrogen peroxide is another sanitizing agent. When you have, for example, in the aseptic processing, you have your polymeric films, you have to sanitize, you have to sterilize them. Typically use hydrogen peroxide, so that you can able to get your surfaces sanitized and so on. Now, if you use above certain concentration like 5% or above, it can cause eye and skin irritant. And PAA, peroxylic acetic acid, probably has a pungent odor, and above certain concentration it is toxic. So, remember, when you use a sanitizer, when it kills the bacteria, chances are above certain concentration it can affect the human, or it can affect any other animals and so on. So, you have to use just enough concentration to kill the bacteria, and then you have to make sure you remove any residue left over, so that it does not affect when you start processing food again. And then you have bromine, which basically focus on spores, and then you can possibly combine with the chlorine to increase the effectiveness. So, we talked about dry sanitation, like where the environment you cannot use water, and so under those conditions you may be using something called superheated steam or dry ice cleaning. So, basically what you are doing is, so let us first talk about the dry sanitation environment. When you have nuts, when you have snacks, baked goods, confection, spices, all these examples for dry sanitation plants. And when you do a wet vacuum, it is okay use water, whereas in the case of dry vacuum, you are going to just remove the surface soil, but it may not remove it does not use the water under those conditions. So, what is superheated steam? So, the dry sanitation in food processing plant is still an active area of research, because there is no solution is being found. So, basically in the superheated steam, you take water and then make a steam, and then you heat further. So, water boils at 100 Celsius, then you heat it further to say 250 Celsius or 300 Celsius. So, the steam water turned into water vapor. What that means is, if you take a piece of paper and then you spray steam, it is probably going to get wet, because the paper is going to condense, trap this steam, and then it is going to condense on the surface and it get wet. On the other hand, when you have the superheated steam, it has a lot of latent heat. So, when you pass it through, it is going to burn. So, that means it has a lot of latent heat, that means the water vapor is not going to deposit. so there is no deposit or water deposit on the surface. So, it behaves like a gas, but it is 100% water, you do not use chemicals and there is no condensation after use, and you can use it to inactivate various microorganisms. So, I think the research done at Ohio State and some other Cornell and other universities suggests that this can be one potential solution for sanitizing dry sanitation plants. So, it just shows here what we already talked about. You take water and then you produce steam. This is what they call wet steam. It is visible, whereas in this case dry steam is superheated steam is going through, but it is kind of not very visible because it is high latent energy. The next one is dry ice. So, dry ice, if you remember, it is the carbon dioxide in the solid form. So, you kind of similar to superheated steam, you apply dry ice on the surface, so that you can able to get the sanitation done, because carbon dioxide is a good bactericidal agent. So, you can able to achieve similar thing, but again carbon dioxide, this method may be more expensive. So, recently there has been some effort where they are taking certain alcohol and then using some type of plasma technique, they vaporize the alcohol and then you apply that vaporized alcohol on the surface as a sanitation dry sanitation method. So, that is another method being looked at. So, there is a lot of new approaches being looked at, but I think you probably on the other one I have come across the literature use, they took hydrogen peroxide and then try to vaporize it and then neutralize, so that it does not have any harmful effect for the humans, but use that as a potential sanitation agent. So, there is a lot of innovations taking place in this space. So, eventually the dry sanitation can also be done much more effective. So, in summary, the cleaning food surface is basically very important, and we kind of reviewed the definition for clean in place, clean out of place, and it is important to have certain concentration, temperature and mechanical action, so that you can do your effectively clean and then sanitize the surfaces. So, these are just some suggested references, and we can have some discussions. I think there should have been some step to remove the application at some point later in the system. So, I think I am not that familiar with that particular operation, but there should be some step they may be using. It is always important to make sure you get rid of that any potential residue.
Sure. Thank you.
One of the other thing is, most of us here are food scientists and engineers. Unless you get into sanitation, you probably not going to never do sanitation in your life. And what I am trying to say is, usually what happens is, when you are processing in a plant environment, once everybody is gone, then the sanitation crew come in, probably at odd hours, and they do all the cleaning and sanitation. So, generally the rest of the people may have a less appreciation for sanitation, because they never seen that is in operation, but that cleaning and sanitation is very critical for the remainder of the day when you are doing processing your food, because if they do not do the sanitation cleaning properly, you can get lot of cross contamination that result in outbreaks and things of that nature. So, you have to make sure you can do it properly. Another example I can tell you is, like we talked about chemical, removing chemical and so on. So, there is a cantaloupe, cantaloupe fruit, they normally use water and then maybe some amount of chlorine. So, there was a time a company, they were trying to get rid of chlorine because they worried people don't want chemicals in the thing. They were just using water without any chemical intervention. Then you had certain bacteria get into that, and then it resulted in outbreak because people just thought, okay, get rid of chemicals, but they didn't thought through, in the absence of chemical, what other thing can do its job to preserve the, take care of the microorganisms. So it's important to pay attention to some of those details.